Okay, first thing I'd like you to do is take a look at this application problem. And this is from lesson 1. It says, the line plot shows the number of miles run by Norland in his PE class last month, which is rounded to the nearest quarter mile. And it has 3 questions underneath of it. It says, if Nolan ran once a day, how many days did he run? Then B, how many miles did Roland run altogether last month? And the last one, look at the circled data point. The actual distance Nolan ran that day was at least blank, then blank mile. So go ahead and try to figure those out yourself first, and then I'll go over with you. Okay. Now let's take a look at the data we have first. Now, if we look at our line plot, we can see it goes all the way up to 1 mile. Now, every X is going to represent each day that he ran, because it says the line plot shows the number of miles run by Nolan in his PE class last month, which is rounded to the nearest quarter mile. So, instead if he ran once a day, how many days did he run? Well, if I come up here and look, each one of these X's is going to be a day, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So he ran 10 days. So his first one, he ran 10 days. Then next is how many miles did he run altogether last month? Well, this isn't going to cause me to have to add everything up. But if I use the line plot, it makes it simple. Because I can see here I have 4 quarters. 1 quarter, 2 quarter, 3 quarter, 4 quarters. And that's going to equal 1 whole right here. Now for my halves, I got 3 halves. Well, 3 halves is going to equal 1 1/2. If I come to my 3 quarters, I end up with 2 of them, so I got 6 quarters, which is going to equal 1 2/4, which is also equal to 1 1/2. And the last one is 1. So now if I look at my overall problem, I can see that I have 1 plus 1 1/2 plus 1 1/2 plus 1. So I add my wholes, I can see I have 4 plus 1/2 plus 1/2, which equals 5. So he ran a total of 5 miles. Now the last one says, look at the data, circle data point. The actual distance he ran that day was at least, I can see that it was at least 1/2 a mile, and it had to be less than 1 mile. Because if he'd run a little more than a half, excuse me, he had to run just a little bit more than a half because it was rounded to a 3 quarters. And it had to be a little less than a mile because it was rounded to 3 quarters. Okay? All right. Now, Module 4, we're going to look at interpreting fraction as a division. I've already talked this over with some of you. So this is just kind of like a review for some of you. For some of you, it will be something new. Now, the standard is MAFS 5 NF23, which is interpret a fraction as division of the numerator by the denominator. In other words, A/B, which could be fraction AB equals A divided by B. You'll see, I'm sure you'll see that pretty quick, that it's pretty easy. And then we're going to solve word problems using division of whole numbers leading to numbers in the form of fractions or mixed numbers. And it says by using visual fraction models or equations to represent the problem. Now that's part of the standard, so you have to be able to use visual models. And that's what we're going to focus on today. Now the learning difficulty on this one is a 2, and it's where you have to rewrite a fraction as division problem and use models to solve. Essential question, how can a model be used to represent a division problem? Well, let's look at our first problem here. Here I've got 2 divided by 2. Well, as you can see, if I have 2 blocks and I'm going to put them into 2 separate spots, I can put 1 in each. So 2 divided by 2 is obviously 1. All right. But look at now. Now I have 1 divided by 2. So now I'm taking this one block here, and I'm dividing it into 2 pieces. So in this case, I need to take this piece over to here and this piece over to here, so I can see that 1 divided by 2, each one would get 1/2. So 1 divided by 2 equals 1/2. All right, what about 1 divided by 3? Well, and the same thing, if I come up and I divide my square into 3 equal parts, and I'm going to put 1 part here, 1 part in this one, and 1 part over here. And as you can see, 1 divided by 3 would be 1/3. Now we got 3 divided by 2. What's the difference on this one? We're dividing a larger number by a smaller number this time. So, since I'm dividing them by 2, I'm going to take and I'm going to divide each one of my squares into 2 parts. And I can see that if I took this one to here and this one to here, and if I took this one over to here and this one into here, I would have started off with 1 whole in each, or 2 halves. Okay, but I still have 1 whole left, which I need to take 1 of them to here and 1 of them over to here. So now I end up with 3 halves in each circle. So we know 3 divided by 2 equals 3 halves, which is equal to 1 whole and 1/2 at each circle. Now 4 divided by 2. Well, keeping the same routine we're doing, I'm taking each whole and I'm dividing them into 2 parts. So now I can take this one to here and this one to here, this one to here, and this one to here, and this one to here, this one to here, and this one here, and this one to here. And I can see that I actually have 4 halves in each circle. So 4 divided by 2 equals 4 halves, and 4 halves is equivalent to 2 wholes. All right, one more. Now we got 5 divided by 2. And the same thing, let's go ahead and split up our 5 wholes into halves. Okay, so I'm going to take this whole into this one, this whole into this one, this whole into this one, this whole into this one. So now I've got 2 holes in each one, but I still have 1 remaining block. So I end up having to take this one over to here and this one to here. So now I end up with 5 halves in each circle, and 5 halves is equal to 2.5 because 2 goes into 5 2 times with 1/2 left over. All right, so hopefully you've made the connection by now. Okay, so if I have a problem such as 1 divided by 2, if I rewrite the problem as a fraction, that is the answer. And that's why fractions are so versatile and they're easy to use. In the same instance, if I had 5 divided by halves, it is equal to 5 halves. It always works. Okay, now we've shown you by the models how that represents that. So now when you go back to class, we'll give it a try. All right, have a good weekend. We'll see you tomorrow.